Hello guys!
So today, we're going to experiment on kinetic energy of rotation and torque.
And we're going to discuss the 6 topics or subtopics in this area.
Of course, we're going to make sure that we will discuss it thoroughly of each concept. So what are we waiting for? Let's go!
So in this video, we'll break down the key concept of torque and rotational dynamics, such as kinetic energy and angular acceleration, and how cross product and initial torques influence motion. We'll also reflect on real-life experiences where understanding this concept could be or could have made a big difference. So first, kinetic energy of rotations. Rotational kinetic energy increases with angular velocity, such as or just like how a spinning bike wheel gather energy as you pedal faster. By understanding this, you can pedal more efficiently uphill. Second, torque and rotational dynamics. Torque, the rotational equivalent of force. It is what helps turn objects like wrenches and open doors. Help to apply force at the right distance and angle can make tasks easier, and as I learned in carpentry when tightening screws. So third, cross product and torque. The cross product helps me calculate torque when force is applied at an angle. For instance, using a wrench at the correct angle improves efficiency, something I learned while losing a ball. Fourth, torque and angular accelerations. So the more torque applied, the greater the angular acceleration of an object. This relationship helps control the speed of machinery as an essential lesson I pick up while avoiding equipment breakdowns. So last, internal torque and balance. In system with internal torque, opposing force can cancel out, leading the balance and stability. This principle became crucial when I struggled to stabilize rotating object during a project. So overall, mastering torque, rotational dynamics, and energy distribution helps solve practical mechanical problems and enhance everyday tasks. Okay. So I'm going to show you an experimental setup for rotational dynamics concept. First, kinetic energy of rotation. So in this example, I'm going to spin a can with a string measure the time and number of rotations. So the key concept of this is the faster an object rotates, the more kinetic energy it stores. This energy depends on mass and angular velocity.
So the second concept is the introduction to torque and rotational dynamics. So for example, apply force at different distances from a door's hinge and observe how torque affects the object. So torque is the product of force and distance from cycles, making it easier to rotate objects on farther points. So the next is cross product. So I'm going to take this weight and put this on the roller. I'm going to put this on a different angle to see the difference and try to calculate the torque and the torque using the cross product. So the concept here is where the cross product helps the effective force contributing the torque, especially when the forces are applied at angles.
This concept
Ayun na,
is...
ayun na. Yeah.
1, 2, 3, go. So the next concept is torque. Example, place weights at different points of the ruler and balance it. Torque increases with the distance from the pivot, making it easier to rotate objects when the force is applied farther from the axis. Mora!
Fifth, relationship between torque and angular acceleration. Use a coin and roll it in the ruler. Observe how increased force leads to faster angular acceleration. The concept is greater torque results in greater angular acceleration, demonstrating the relationship between force and rotational speed.
So, the last concept is internal torques cancel in pairs. So, for example, is place equal weights on both sides of balance bar to observe how torques cancel each other out, maintaining equilibrium. So, the concept here is, in balance system, internal torques cancel leading to stability, and balance force causes rotation.